All right, so this is going to be the last lesson in this unit. I just want us to make sure that we understand how to do all kinds of factoring. So we're looking at factoring of special cases. There's nothing that we're going to do today. Well, maybe there's a little bit of what we're going to do today there's nothing that we're going to do today that you can't do in any of the forms that we've done so far. So far, important things, common factoring. That's always number one. If you can common factor any expression that you have in front of you, then you factor it, okay? Common factor it always first. Then you check and see, do I have a simple trinomial left? Or can I factor it like a simple trinomial? And if the answer is no, then you say, all right, then I'm going to do it by complex trinomials. And these are the major ones. There are some subsets of all of these. There's one called, which is the very first one here. This is called and we've actually already did some in the last lesson. It's called a perfect square trinomial. All right. So what a perfect square trinomial is something that is the square of a binomial. So like the number, let's say, like the number 49 equals the square of 7, you can get a trinomial that is, if you take a binomial and you square it, that will give you that trinomial. And in fact, any binomial squared is always a trinomial. It's not a binomial. So let's say, for instance, you had the binomial 3x plus 5, and you wanted to square it. A lot of people will say that the answer is 9x squared plus 25, and that is wrong. Because they'll just take the 3x and they'll square it to get 9x squared, and they'll take the 5 and square it to get 25. Bada boom, bada bang, there's your answer. Well, actually, that's wrong. Because 3x plus 5 squared means 3x plus 5 times 3x plus 5. Which means you've got to expand this out like you would any other binomial times a binomial question. So 3x times 3x, yes, that does equal 9x squared. So yep, there is a 9x squared in the answer. But 3x times 5 is a 15x. And then a 5 times 3x, that's another 15x. And then 5 times 5, yes, there is a 25. Oh, there is a 9x squared and there is a 25 in the answer. But there is also that nasty little middle term in there that you can't forget. So when you square a binomial, you always get a trinomial because there's always that nasty little middle term in there. Always, always, always. Okay, so this is what we would call this 9x squared plus 30x plus 25. That would be called a perfect square trinomial because it is the square of a binomial. Well, this question here, 4x squared plus 12x plus 9, is also a perfect square trinomial. Well, let's see what makes it a perfect square trinomial by looking at this one. Well, this is a perfect square. 9x squared is a perfect square. What's it the perfect square of? It's the perfect square of 3x. 25 is also a perfect square. What's it a perfect square of? It's a perfect square of 5. Well, how do we make sure that this is definitely a perfect square trinomial? Well, if we take the 3x, which is the square root of 9x squared, and we take the 25, which is the 5, which is the square root of 25, if we multiply those two together and then double it, because that's what happened here, we did 3x times 5 to get 15x, and then we did it again, so we doubled it to get the 30x. So if I go back to this question here, the 4x squared plus 12x plus 9, what's the square root of 4x squared? Yes, you're right, it's 2x. What's the square root of 9? You're right, it's 3. What's 2x times 3? You're right, that's 6x. Double it equals 12x. Then yes, that is that middle term, which means this definitely is a perfect square trinomial. And what is it the perfect square of? It's the perfect square of 2x plus 3. Just like 9x squared plus 30x plus 25 is the perfect square of 3x plus 5. Okay, that's one way of doing it, but you always have to double check to make sure that that is a perfect square trinomial. Your other option is to go back. This is a complex trinomial. So if you were to factor it, you can always go back to, I'll call it first principles. 4 times 9, that's 36. They add together to give you 12. 1 and 36. 2 and 18, 3 and 12, 4 and 9, no, yes, 9, 6 and 6. This has got to be 6 and 6 because they have to add up to give me 12. So then that would be 4x squared plus 6x plus 6x plus 9. Common factor these, that's 2x, 2x plus 3. Common factor these, that's 3. 2x plus 3 gives you 2x plus 3 times 2x plus 3, which is 2x plus 3 squared. So you have a choice. You can either notice that it's a perfect square trinomial, or you can go ahead and factor it like it is a complex trinomial. Okay? Another subset of sometimes a simple trinomial, because we did one like a couple like these under simple trinomials, or complex. So this one looks like a complex trinomial. Well, it doesn't even look like a trinomial. It looks like a binomial because there's only 2 terms. But it's technically a trinomial with the 0 term missing. Let's just say that. Sorry, with the x term missing, not the 0 term, the x term. So this is what we call difference. What does the word difference mean in math? What operation? So subtraction of squares. Well, what does squares mean? Well, it's a square. You multiply something by something. 4x squared is a perfect square. It's the square of 2x. 9 is a perfect square. It's the square of 3. Before I do that, though, I'm going to treat this like it's a complex trinomial. So technically, this would be 4x squared plus 0x minus 9. So I'm looking for 2 numbers that multiply together to give me negative 36 and add to give me 0. Well, the only way that's going to happen, they can only add to give me 0 if they're the same number. One is positive, one is negative, and to multiply to give me negative 36, I need 6 and negative 6. So that is y equals 4x squared plus 6x minus 6x minus 9. These 2 factor to a 2x. That's a 2x plus 3. These 2 factor to a minus 3. That's a 2x plus 3. I took out a minus 3 here. Always take out a negative. This has always got to be the same sign as that. Okay, and then I have 2x plus 3 in common, and then a 2x minus 3. See what happens there? This isn't a binomial squared. It's a binomial where the 2 terms are the same, but one is positive and one is negative. And that happens all the time. So technically what happens with difference of squares, here's the formula for difference of squares. If you have something squared minus something else squared. So in this case, the something squared was 2x and this something else squared was 3. To factor that, you just do the square root of each of them. Same thing in each bracket, except one has subtraction and one has addition. And that's how you can always do it. So just, here's another example. So 81x squared is the square of, well, the square root of 81 is 9, and the square root of x squared is x. Square root of 25 is 5. So I'm going to put a minus in one bracket and a plus in the other. There is no such thing as sum of squares, factoring sum of squares. It just doesn't work. You can't do it. So if you have a squared plus b squared, this is not factorable. Okay, because let's just pretend it was 4x squared plus 9. All right, so 4x squared plus 9. All right, so that's the same as 4x squared plus 0x plus 9. So I need two numbers that multiply to give me positive 9 and add to give me 0. Well, the only numbers that multiply to give you 9 are 1 and 9 and 3 and 3. I add those together, I'm going to get 10 or I'm going to get 6. I can't add them together to get 0. It can't happen. Can't happen. Okay? So a squared plus b squared is not factorable, and that's a really key concept in many different branches of math. Today I'm not worried so much about being able to state what the x-intercepts. I just want to be able to factor these, because some of these we're not even talking like, look, this isn't even a quadratic anymore. This has got an x to the 4 and it's got all sorts of things. So this is really just a factoring exercise today. It's not really doing anything graphically. Okay, and notice it doesn't even say y equals. And then look at this next crazy one in part B, like the y's on the other side of the equation. So these are not equations, these are just expressions, and we want to be able to factor them. Okay, so this next one here, first and foremost, always try to common factor. Okay, that's number one. So I'm going to factor out a negative because that first term is negative, and I hate negative first terms. And it looks like both of these are divisible by 2. And they both have an x square in them too. All right, so I need to multiply negative 2 times 9 to get 18, and I need to multiply x squared by x squared to get x to the 4. And I need to multiply negative 2 by negative 16 to get 32. And I've already got my x squared. All right, now I notice that 9x squared is the square of 3x. I'm just going to put that down in blue. This is the square of 3x, and then this is the square of 4. Both of these numbers are perfect squares, which means we're also talking about difference of squares here. If those two weren't perfect squares, if it wasn't a 9, like let's say it was a 7, and the 16 was like a, I don't know, 11 or a 24 or something, it wasn't a perfect square, then you wouldn't be able to do this next step. So now, this is difference of squares. So back here, difference of squares, this is the pattern all the time. So that's going to be 3x minus 4 and 3x plus 4. And now that is factored fully. All right, let's take a look at the next one. There's a lot of terms here. Okay, they all have a y in them. They don't all have an x in them though. They all have a y. So I'm going to take out a factor of y. See what I'm left with. X to the 5 plus x squared y squared minus x cubed y squared minus y to the 4. Let's try factoring by grouping. See if that gets us anywhere. And remember, when you're factoring by grouping, it doesn't matter how you group them. It should work. It should work in any way. So I'm going to use a square bracket because I'm going to be common factor. So common factoring these first two, they both have an x squared in common. And then I'm left with an x cubed plus y squared. And now common factoring the next two terms, they both have a negative. They both have at least a y squared in common, and I'm left with x cubed plus y squared. Okay, so factoring by grouping worked. And you know it works when these two brackets have the same thing in them. If they don't have the same thing in them, then factoring by grouping doesn't work, and you can't go any further than what we had in this line here. So now I've got x cubed plus y squared, and then I've got x squared minus y squared. Well, the x cubed plus y squared won't do anything. Number one, it's addition, and number two, they have no common factor. There's nothing there, so that's just going to be a y x cubed plus y squared. Notice how sometimes I write my y's like this, and sometimes I write them like that. I don't know why I do that. Okay, x squared minus y squared. Look at that. That's the same thing as this right here, except it's got a's. It's got x's and y's instead of a's and b's. So then that's x minus y, x plus y, and you're done. All right, next one. They have nothing in common. Remember, common factoring first if you can do it. Common factoring first. Well, 81x to the 4. When I see numbers that are perfect squares, I immediately start thinking difference of squares. And as long as the variable parts are also perfect squares, then it is difference of squares. Well, two things have to be true. It has to be subtraction. Okay, so 81x to the 4 is the square of 9x squared. And 16y to the 4 is the square of 4y squared. So then that means that this must equal, so it is difference. It is subtraction, so it is difference. So that would be 9x squared minus 4y squared, and then 9x squared plus 4y squared. All right, now 9x squared is the square of 3x, and 4y squared is the square of 2y, and it's difference again. So we can go even one step further. We can say this is 3x minus 2y, 3x plus 2y, and then 9x squared plus 4y squared. This is not factorable. This is that addition. This thing here, a squared plus b squared, is not factorable. Okay, so we're done. We've fully factored. It can't go any further than that. So the answer is all of that. All right, this next one. X to the 4 is the square of x squared. 625 is the square of 25. So this must be x squared minus 25, x squared plus 25. Now x squared is the square of x, and 25 is the square of 5. So this is x minus 5, x plus 5, and then x squared plus 25. These two questions are basically the same. Basically. All right, this one. Okay, x minus 3 squared is the square of x minus 3. And x plus 5 squared is the square of x plus 5. So this must equal, I'm going to put this inside square brackets, x minus 3, and again, it's difference. So it's difference of squares. X minus 3 minus x plus 5 times x minus 3 plus x plus 5. And if we simplify this, this is going to be x minus 3 minus x minus 5. And x minus 3 plus x plus 5. The x minus x, that's no x's, so this is a negative 8 times a 2x plus 2. This, you can factor a 2 out and be left with x plus 1. So this is negative 16 times x plus 1. That was a weird one. Okay, this next one. Well, notice, what if we did this? This looks like a trinomial, right? Except this is an x to the 4 and this is an x squared. Now, just let me do this. Let's let a equal x squared. So therefore, if I was to square a, that means if I square this side, I have to square this side. So that would be x to the 4. So this x to the 4 is really a squared. And then this x squared is really minus 8a plus 16. This is a trinomial. Two numbers that multiply to give you 16, add to give you negative 8. I believe those two numbers are negative 4 and negative 4. This is a simple trinomial. So with a simple trinomial, you can go right to the brackets. With a complex trinomial, you have to go through decomposition. So since those are the two brackets, that's just a minus 4 and a minus 4, which is a minus 4 squared. However, a isn't what this question started out as. It actually started out with x's. Remember, a was equal to x squared. So then this actually becomes x squared minus 4 squared. But now this crazy thing is difference of squares. So this is x minus 4, nope, sorry. X minus 2, x plus 2, all squared, which is x minus 2 squared, x plus 2 squared. Now it's fully factored. That was a crazy one. All right, G, 81 minus 16a squared b to the 4. 81 is the square of 9. 16a squared b to the 4. Now the reason why I'm doing this is right away, as soon as I see subtraction between two terms, I immediately try to determine if it's difference of squares. 16a squared b to the 4, that is the square of 4ab squared. So this equals 9 minus 4ab squared, 9 plus 4ab squared. This one we can't keep going because even though 9 is the square of 3, 4 is the square of 2, b squared is the square of b, a is not the square of anything except the square root of a. So we don't go any further. There's nothing there, so we can't use difference of squares again. Okay, so remember, 1 common factor first. So like if you had a question like this, 3x squared minus 75, common factor that first, so they're both divisible by 3, and then that's x minus 5, x plus 5, because x squared is the square of x, 25 is the square of 5. All right, common factor. Then you see, do you have a simple trinomial? Actually, you know what I asked myself first? How many terms do I have? If I have 2 terms, then I check to see if its difference of squares. If I have 3 terms, then I ask myself, is there, so here, this is what I would do. Number 1, I would common factor. That's always number 1. Okay, so then I say, all right, 3 terms or 2 terms. Then I ask myself, is it difference of squares? If not, I move on. Well, there'll be nothing to do. Because if I've already done common factoring, and if it's not difference of squares, there's nothing to do. It's not a trinomial. Okay, 3 terms. Is it simple or is it complex? Okay. And either one of those, you could ask yourself, is it a perfect square trinomial? But honestly, I wouldn't waste my time, really. You can memorize what a perfect square trinomial looks like. So this little bit here where when you take the square root of the front and the square root of the end number and then you multiply them and then double, and if that's the middle number, then it is a perfect square trinomial. If you want to do that, you go ahead and do that because that makes, oh, sorry, I didn't put the square on here. Sorry about that. So if that's the case, then that makes it easy for factoring. Otherwise, you can go through the whole complex trinomial factoring of it. You'll probably notice as you go, oh, this was a perfect square trinomial because when these two numbers are the same, when you break up that middle term and it breaks up into the same 2 numbers, like the exact same numbers, not the opposite of each other, then you definitely have a perfect square trinomial. Okay, so here's some homework for you to try. Page 230, numbers 3 to 7 and 10 and 11, and that is going to be it for this week.